Okay, so this is actually on your practice paper. Okay, we're going to continue with question number 9. Okay. So remember the last time I told you, when doing any questions, you want to be able to identify the topic and then after that the concept. So let's take a look. First step is to read the question like what I've told you previously. Now, Elson bought some plasticine as shown in diagram A. He then cut it into 5 equal pieces. Okay? Which of the following correctly represents the total mass and volume of the 5 pieces of plasticine that Elson had cut up? Now, what happens over here is that they are testing you the concept of the topic over here would be matter. And the concept over here that they are testing you, since talking about mass, right? So they are testing you on the concept whereby matter has a fixed mass. Now, in fact, all matter have a fixed mass. So just in case y'all don't understand what is mass, okay? Mass is the amount of substance used to form something. Okay? It is different from weight. Weight is actually got to do with gravity. It's a gravitational pull. That is weight. So mass, we're talking about mass, right? Is actually the amount of substance used to form an item, or the amount of substance that an item has. Alright, so that is mass. Now, mass and volume are two very different things also. Volume is the amount of space that something occupies. Alright, so for example, in a very, very simple way, let's just say we have 2 different items of the same kind of, let's say I got 2 balls over here. 2 balls of similar size, but they are made up of different materials. So ball A is made up of metal, and ball B is actually maybe say made up of plastic. So when you put it in on a weighing scale, though they have the same volume, they are the same size, right? But you realize that the metal is actually heavier than the plastic. Reason being that the metal has a greater mass. It contains a larger amount of substance. Yes, Ping Rong. Okay, wait. Alright, so we say that the metal has a higher mass. Now, density is a totally different thing altogether. Okay? So then after that, we go back to our concept. So this is testing you the concept that matter has a fixed mass and a fixed volume for solid. So when in solid state, right, you need to understand that both the mass and the volume is actually fixed. You cannot change that. So an example that can be changed for volume will be your air. Okay? So in this case, they ask you which of the following correctly represents the total mass and total volume. So remember, the mass is fixed. The volume is also fixed. Now be very careful. The idea here is total volume and total mass. That means when you add these 5 cubes, 1, 2, 3, 4, and 5, because they came from the same block, and your mass doesn't change just because it's been cut up, alright, it should remain the same. So the total mass, when you add up all these 5, must be the same. So it remains the same. So anything that changes, decreases, or increases, straight away you cross it out. No need to see already. You can do this by elimination method. Now, then after that, so this 2 is correct, right? You need to check also. So once again, remember for solid, it actually has a fixed volume. So because it has a fixed volume, right, you need to understand that it should remain the same, even though you chop it up. Okay? So in this case, this is wrong. So the answer is number 4. Both of them should remain the same. Okay? Now, moving on. Okay, I'm just going to pause here for a while for you to copy. So I just want to talk a little bit about mass. So mass is the amount of substance that makes up an item or an object. So it does not change, but weight has got to do with gravitational pull. So basically, gravitational pull is different on different planets. So this is why you weigh a lot lesser on the moon. If you were to go onto the moon, your weight will drop. That's because the gravitational pull on you on the moon is lesser. But it doesn't mean that the amount of substance that you are made up of changes. That's why your mass does not change. I want to be very clear about that. Your mass does not change in that sense. Okay? But your weight changes. You need to be very, very clear about that. Next. So once again, step 1, read the question. Step 2, identify topic. Step 3, what is the concept they're testing within that topic. Darryl filled up a container with marbles until he could not put in any more marbles. He said that there are no more space in the container. His teacher disagreed with Darryl. Which of the following actions should Darryl's teacher do to prove that Darren was wrong? Now this is a very controversial question. In fact, I think it's something that is very, very problematic, because the fact that there is no more space in this case is actually correct, because space means that it's emptiness in that case. Actually, what they are trying to say is more things can be added in it. So no more space means that it's actually empty. But in actual fact, right, if you ask me, when you take a look at this container, okay, and you zoom in, I'm just going to shade for you. The areas that I shade in red, they are not really empty. Okay? They are not really empty spaces. So I have an issue with this question. This question is, when it appears as an MCQ question, it actually poses a problem because it's not really empty space. It is occupied by something. Now this something over here is your air spaces. So this is where students tend to actually get confused. Joe, you say it's not empty, or you say it's empty, but actually it's not empty because it's occupied by air. You understand what I'm saying? Air is a matter, right? It's occupying space, right? It's occupying these spaces. So technically, Darryl is correct. But in this case, they said that he is wrong and the teacher is correct. So this is why, right, in exam, you need to get the best possible answer for MCQ. It's always the best possible, because sometimes MCQ questions may not be 100% factually correct, because in this case there is really no more empty space because the empty space is occupied by your air. Okay, now this question actually came up for your topical practice, if you recall, and in your topical practice you have to say that when you pour water, it displaces the air from the spaces between the marbles, remember? So this shows that it is not empty. So Daryl is right to say that there is no space. So if let's just say you were to seal this up, okay, the only reason why you can even add in more water or more sand is because air can be compressed. It's not empty, it's just that air can be compressed. So in this case, this question is a bit problematic and I have an issue with it. Okay, but because let's say this is exam setting, and this question comes out, I'm going to have to assume that the teacher is right. Okay? So which of the following actions should Daryl teacher prove to Daryl that he is wrong? Okay? That means he can fill in more things. So you can actually pour sand into the marbles. Okay? Because as the sand trickle in, okay, you can actually fill up the spaces here. And the reason why you can fill it up is because air can be compressed. And it's not because that it's empty, it's because air can be compressed. So you cannot say that there's empty spaces in it, okay? So it's a bit funny because in a way there is still space, but the space is created. That means you cannot say that it is totally empty, it's filled with air. But it's only created because as you pour the sand in, you compress your air in between the marbles, okay? You can also pour water into the container of marbles because the water is able to take any shape. So it will come and it will actually take up, squeeze the air or displace, because this is unsealed. So you realize it's not sealed up, the air can actually escape. So as the water get poured in, it will displace the water out. Do you remember that was the answer for one of your topical practice? So your answer is A and C only. Yes, Ethan?
If you seal the container but then you pour in some water, will the water like float because the air will be compressed and it cannot escape?
No, because air has a greater density than air. So what you pour the water in, okay, and if it's sealed up, what will happen is some of your air will get compressed. And then it will allow some water to flow in, okay, but water will still be at the bottom because it has a higher density. So it will sink as compared to air. Alright, good question. So moving on to question 11. So Nelson filled 2 identical beakers with 50 ml of water each. Now take note, this kind of question, right? Okay, usually the volume is the same. He then lowered object A into beaker P and object B into beaker Q. The diagram shows the result of the experiment. What conclusion about object A could Nelson make from his observation shown above? So in this question, the topic would be on matter once again. And the concept that they are testing you on, if you take a look at it, is that matter occupies space. Alright? So, usually for this kind of question, right, it's based on the concept of matter occupies space. In this question, because they tell you already 50 ml, then they also show you the measuring and the amount of water increment. So this tells you that they want you to find out what is the volume, what is the amount of space occupied by each object. So because they gave you the initial level, any increment has got to do with the amount of space taken up by the object. So for example, in object A, you know that it's at 60. However, the original amount if you remember, is actually 50 ml. So if you want to know what is the volume of object A, you will take 60 minus away 50 ml to give you 10 ml. Now, we don't really use ml for size of object. We use something called cm cube, but it's a 1-to-1 ratio. So it's also equivalent to 10 cm cube. Now, compare this with object B. Once again, the original level of the beaker is actually at 50 ml. However, now it is actually at 100 ml. So to find out what is the volume of object B, you will take final volume minus away initial volume, which is actually 50. You will get 50 ml, which is equivalent to 50 cm cube. So this unit is used for talking about the volume of solids, usually in labs. You can use ml, but ml usually is more for liquid. So I prefer to use, or the convention is actually cm cube for solids. So I'm going to write down the formula for you for finding out volume of object when you use a measuring cylinder or a beaker. So the formula is actually final volume minus initial volume. Initial means at first, okay, equals to volume of object. Okay, so initial volume for this is 50, final volume it depends. It can be 60 for object A and 100 for object B. So now that you've worked out the answer, you can then go on to the options. So object A can be compressed. This is wrong. This experiment doesn't show that it can compress. Okay? Object A has no definite shape. Once again, it also does not show. Object A is lighter than object B. No, there is no measuring scale. So I'm not measuring that. Object A has a smaller volume than object B. This is true because object A is 10 cm cube versus object B, which is 50 cm cube. So your option would be number 4. Very straightforward. Okay, moving on to the next question in 5, 4, 3, 2, and 1. Next, Rita put a test tube of water with a temperature at 70 degrees Celsius. Once again, I want to stress when you write this unit degree Celsius, make sure it's degrees Celsius. Okay, with the degree at the top. This is called superscript. Now, so what happens is that which of the following correctly shows the heat gain and heat loss of crushed ice of water in the test tube? So this topic, if you look at it, the key word is heat, correct? Temperature. So all this will hint you that, okay, the topic in this case would be heat. Now the concept in this case that they're testing you, based on what I've read, is talking about heat gain and heat loss. So these two words will hint you that it's talking about the transfer of heat. This is the concept. And straight away when you talk about heat transfer, it should bring you to the very important rule, which I've repeatedly told you that, which is this. Write this down. Heat always travels from a region of higher temperature to a region of lower temperature. This is very important. I know I've repeated this so many times. However, there is still an issue with people not following this rule or cannot remember. So if you actually, based on the concept of transfer of heat, you remember this very important rule, the first thing you need to do is that you need to actually tell me, okay, which region has a higher temperature and which region has a lower temperature. So they are comparing crushed ice with water in the test tube. So this crushed ice, we will say that it is, let's just say it is region A. And then after that, the water is called region B. Now you need to ask yourself, between these two, which one has a higher? Because based on what you tell me, always travel from a region of higher to a region of lower. So it's a relative term. That means it's comparative. So you need to compare these two regions. Now, crushed ice and water at 70 degrees. Which one is a higher temperature? Ice is actually at 0 degrees and below. So when you compare the two, okay, you are actually looking at your water being a higher temperature. Yan Hao, behave yourself. So what happens is that you need to understand, so in exams you always write this, an up arrow and a down arrow. So you know that the up arrow means that it's got a higher temperature, and then the down arrow shows that it has a lower temperature. So this will tell you that heat always travels from a region of higher temperature, which is your water, out to your lower temperature region. So in this case, if you take a look at it, your water is losing heat because heat is going up, ma. So straight away, anything that is gain heat, you know is wrong. Cross out these two. Okay, so lost heat is correct. And then your crushed ice should be gaining heat. So this is correct and this is wrong. So your answer would be number 1. Now I want to stress that there is no such thing as gaining coldness. For the 101 time, stop it. I do not want to see this in exam. Not from you, because I have repeatedly tell you that there is no such thing as gaining coldness. A lot of people always say that, oh, the item cooled down in the fridge because coldness went into the can of Coke. No. The reason why it cooled down is because heat from the can of Coke actually got lost, okay, to the cooler environment of the fridge. Eventually, it became the same temperature as the fridge. So if you set a temperature of your fridge at 3 degrees and your Coke is at, say, 30 degrees because out in the open, eventually it will keep losing heat until the temperature of your Coke reaches 3 degrees Celsius. Not because it gained coldness. I want to stress that. Yes, Ethan? No, the Coke will not freeze because I said 3 degrees. Okay, freezing point of water is at 0 degrees. Yes, Sam?
I still copy the heat always travel. Okay, done.
Alright, moving on to the next question. So answer is number 1 for this one.
Yep.
Now 13. The diagram below shows 2 glasses, A and B, which are stuck together. Now this question is a very common question. Okay? What should Johari do in order to separate the 2 glasses A and B? Now you need to understand that for this question is actually, once again, if you take a look at the options given, even though the question itself did not give you any hint, but look, what ice water, hot water, all this will tell you that, hey, okay, the topic is on heat. Now once you got the topic of heat, okay, then you can actually start to think for yourself, okay, so under the topic of heat, there's a few concepts. There's actually measurement of temperature, there is heat transfer, there is expansion and contraction, there's also talking about poor and good conductors of heat. So in this case, looking at this, I can narrow it down that when I need to separate the two glasses, in order to separate the two glasses, one must become bigger, while the other must either remain the same size or become smaller in order to remove the two. So in this case, my concept that I'm looking at would be contraction and expansion due to heat. So once I narrow down, you see, straight away, I know already, okay, so for something to expand, it has to gain heat. And when things expand, it will increase in, it will actually increase in size. Now, as part of your holiday homework, just to sidetrack, I'm actually going to give you a targeted revision worksheet whereby I will tell you exactly how to answer common heat questions. I'll give you the strategy. So it's very, very clear. If you follow my strategy, you will be able to get all the heat questions correct without fail. If you at least follow what I'm about to say. Yes, Braden? I cannot hear you, Braden. Okay, the revision paper, I will give you physical copy. And then what you will do is, I will record a video on SLS on how to attempt these questions with my given strategy. So your job is to go and do it following my video. I will not be checking, this is optional. Once again, this is optional, it's only given to the classes that I teach. That's it. So basically, in this case, I need to expand. So I need glass B to expand and glass A to contract because I want glass A to become smaller. If you take a look at it, glass A is actually stuck in glass B. So I need glass B to expand and I need glass A to contract or at least remain the same. Okay, in this case. So what can I do to actually make glass B expand? I can actually add heat or provide heat. And for it to contract, I know that I need to lose heat. So I need it to somehow lose heat. So I can do that by putting it in ice or cold water or something like that. Okay, so let's check out the first one. Pour ice water into glass B and put glass into glass A and put glass B into a tub of ice water. This is wrong. Why? Because putting in glass A will make it smaller, but putting glass B into a tub of ice water will also make it lose heat and become smaller. So I'm making both glasses contract at this time, which is not what I want. So straight away, one is wrong. 2. Pour hot water into glass A. Then my glass A will expand or contract. Expand, right? Which is not what I want. So straight away, wrong. Pour ice water in the glass A and put glass B in a tub of hot water. Oh, signs of bad, right? So in this case, my glass A will expand and my glass B will actually contract. Okay, this is correct. Let me check the last one to make sure that, okay, I don't have an additional answer. Pour hot water into glass A, so I will expand this, which is wrong because I want glass A to contract. So yes, the only option that we have is actually 3. Yes, Ethan? Yeah, so you want glass A to contract. Okay, thank you. So that was what you're trying to tell me, is it? Being wrong? Okay, thank you. So this would contract. Very good. Okay, so yes, so glass A will contract and glass B will expand. My apologies. Yes. No. Cannot. Sam, you may not sit here because of COVID. So every time you sit, the sitting arrangement changes. So in the case whereby somebody has COVID, we need to do contact tracing. So if you just change place like that, then your sitting arrangement will be different and you need to do wipe down. It's not so simple as, oh, I want to sit here. No, you have to wipe down the whole table, sit here, and then change your sitting arrangement in the sharing drive. It's not so simple. Okay, yes, exactly. So, Hei Long has asked a very good question. His question was, why can't they just heat up glass B? If you just heat up glass B, then no problem. Glass B expand, but glass A will remain the same. However, it is very difficult to actually do that because your heat will actually travel from, let's say I put a heat source here, it will travel from glass B and then it will travel to glass A also. Then A will also what? Expand. So sometimes, right, the expansion can be so fast, okay, because the glass wall is very thin. Alright, so unless you're telling me the glass wall is very thick, then maybe you can just heat up glass B without causing glass A to gain heat and expand at the same time. Yes, Owen? Sorry? Yes, glass A will expand slower than glass B, but sometimes, okay, it is so fast, okay, the expansion that both will expand nearly at the same time. So the safest way is actually to put cold water in glass A but hot water for glass B. So you contract glass A but expand glass B, then the effect will be multiplied because one is contracting and one is expanding. Okay? So that's why I put here either contract or remain the same. Yes, what do you need, Sam? Yes, you may. Okay, next. Siva placed an empty round bottom flask, okay, into a basin of ice cubes. The flask was fitted with a stopper where the glass tube was attached. He added a drop of red coloring to the glass tube. He observed that the drop of red coloring moved down in the glass tube after 5 minutes. Which one of the following statements correctly explain his observation? So when you look at everything, right, then you look at the options, you see words like heat, you see words like contracted, okay? So straight away, you know that this topic has got to do with heat. And once again, the concept that is being tested in this case is probably contraction and expansion. Okay, now, so what you will do is Owen put away that book. Sit up straight. So they ask you, how come the coloring moved down the glass tube after 5 minutes? Okay, now you need to understand that this is ice cubes. Alright, now in order for this red dot, this drop of red coloring, I'm going to zoom in, to actually go downwards, you first must understand what is preventing it from going downwards. Then you'll be able to answer this question already. So think, how come it's floating in the air? Because there is what? Very good. There is actually air particles inside here, okay, that actually prevents air occupies space. So So because air occupies space, it prevents the red coloring from going down. Okay, and so it's like floating in the air. Then, because you understand that it's the the air that is preventing the droplet from going down because it occupies space, the next thing you should do is, okay, how do I then make the red coloring go down? And the only way to do that is to make sure your air occupies less or more space. Less, correct? So you want your air to occupy less space. So to do that, right, you think about it, he put ice, correct? He put it into a basin of ice. So basically what will happen is, remember, what is one of the way that air can actually occupy less space? It's through what? Either being compressed or it has what? Contracted. So in this case, it's not a test of metal. It's not, the concept here tested is not on metal. So this explains to you why identifying the topic and concept is so important. Because if you don't identify the concept correctly, right, you will say that, oh, air can be compressed. But in this case, I'm not talking about that. I'm talking about contraction and expansion. So based on this, I know that something can reduce in size by contracting. And when you contract, you need to lose heat. So in this case, I know that ice cube is of a lower temperature as compared to my air. So heat will be lost from this region to this region. Okay, so when it loses heat, your air will actually contract and occupy less space. So when it occupies less space, okay, the red color droplet will actually go down, will drop. So basically, the air in the flask lost heat to the ice cube and contracted. Okay, the rest of it does not make sense if you take a look at it. So I hope that by me going through this MCQ step by step, you notice that it's really not that difficult to score full marks. It really isn't. When you listen to me, identify the topic, identify the concept, and then after that, do your work. Hannah and Divesh. Thank you. Moving on to the next question. 15. Okay, this one is something that is very common. So sometimes, right, when you are exposed to enough questions, that's where your experience come in. Now, a lot of times, people will tell you, oh, drill and practice is no good. Don't go and memorize answers. It's no good because it doesn't get you thinking. However, I beg to differ. You shouldn't memorize the answers, but you should at least do enough practice so that you have enough experience. In fact, the reason why various CEOs, okay, these chief executive officers, they are paid so highly paid, is because they have been in this industry for many years and they have the experience to solve problems. So I don't believe that you should do less. Okay, by doing more, you are getting exposed to different questions that will help you gain experience. So you can better handle the questions and you are more likely to know the solutions just because of experience. Don't think of it as drill and practice, but think of it as you're being exposed to gain better experiences. Alright? So why do I say this? Because straight away you look at this metal ring, metal ball, you know that, oh, this is a heat topic. No need to see already. And when you see metal ball going through a metal ring, straight away you will also know that the concept is probably 99% expansion and contraction. So I just want to talk about experience being different from just memorizing the answer for the sake of memorizing. So this is one very good example. One look at it, I know expansion and contraction, no need to see already, heat topic. Okay? Now, Mrs. Chua conducted an experiment where she put a metal ball through a metal ring as shown in the diagram. She then hit the metal ball over a pipe for 5 minutes. She found out the metal ball was not able to go through. So based on experience straight away, I know why already, because the ball has expanded. You didn't hit the metal ring, So the metal ring actually remained the same size, but the ball has expanded. Okay, but this one same size, because you didn't hit it. Okay? Now, which of the following statements correctly explain why the metal ball was not able to go through? So basically, the answer would be only the ball had expanded, that's it. You did not hit the metal ring at all. Okay, so it remained the same size. It did not gain any heat apart from it when the metal ball touches the metal ring. Don't talk about that. Okay, that is a different event, a more complex event later on. Okay, so you see, this is one example whereby having enough experience will help you instantaneously solve the problem. Okay, because you're able to identify the topic and the concept straight away. Now, this will be the last question of the day. Okay, now Lily wants to carry out an experiment on two similar plants to find out if the presence of roots affects the growth of plants. She prepared 4 setups A, B, C, and D as shown in the diagram. Which 2 setups should Lily use to carry out the experiment? This question, okay, is not about any particular topic. This question is about, the concept is about conducting experiment. Okay, so the concept is not on any topic. It's about conducting, okay, fair experiment. Now, in order to conduct a fair experiment, I have told you many times, you can only change one item, change one variable, change one factor, or one variable, they call it. So in this case, the variable that should be changed should be the variable that you want to investigate. For example, if I want to know that if eating more will actually make you heavier, basically everything needs to be the same, including the person that is being investigated. So instead of having 2 boys of the same height, of the same weight, you need to have twins, because genetically they are the same, and that's why it's so unethical to conduct human trials like that, because you're forcing one twin to eat more and the other to eat less. So the one that eat more could potentially develop heart problems, and the one that eat less could potentially develop malnutrition. So basically everything must be the same except the thing that you want to change. So in this case, the one that they want to change is actually the presence of roots. So that means one must have root, one must have don't have root, and everything else must be the same. So just based on the look of it, right, your answer should be the amount of water must be the same, and then one must have root and one don't have root. So in this case, alright, your answer, firstly, do you see the amount of water added being the same would be what? A and C. So the only difference that I see between these two is that one has separated the roots, which is what we want. You cannot use any other pair, don't have. In fact, this question is very straightforward. There's only one set that uses the same amount of water, everything else is all wrong. So therefore, answer is A and C. This is very straightforward. Sometimes not so straightforward. Sometimes they can give you a third option, which is actually they cancel this and they give you 150. I would actually pick the 151 together with, I will pick C and D if that were to happen. Why? Because suddenly you add in a plastic bag. But in this case, remember, MCQ question is always best possible answer. So because it's best possible answer, everything else must be the same. So based on this, since both 150 ml, the plants are the same, it's just that setup A has the roots separated from the water, I would assume that that is the one that they use for absence of roots, as compared to setup C, which is the presence of roots. Okay? Now, so for today, I come to the end of the lessons for today. I'm going to stop the record. Okay, so continuing from our previous lesson, we're going to go on to question number 17. Okay? So Dina wanted to find out if the amount of sunlight will affect the growth of plants, which variables should she keep the same? So remember, I always tell you that you should take a look at the question, step 1. Step 2, try and identify the topic and then narrow down to the concept. However, for this question, right, there is not really one topic or one concept. Okay, the one concept that is actually trying to test, right, is actually on, okay, how do you conduct a fair experiment? That is the main concept that they want you to know. Okay. So this is actually a very common question that always comes up for exam. Okay, so you need to understand that in order to conduct a fair experiment, there can only be one, okay, change variable. Now, what do I mean by change variable? Change variable, that means the factor that you want to change. And this change variable, right, is usually connected to the aim of the experiment on what you want to find out. Now, what do I mean by that? So, for example, you want to know if, let's just say, eating more vegetables would actually make you lose weight. So, what you need to do is, you need to actually find, you need to repeat the experiment. The first experiment, right, you would eat the exact same food. Everything is the same, okay, as the one that you're going to repeat. The only difference is that one has vegetable and one don't have. Then you weigh yourself. Okay? Nothing else must change because your experiment is whether or not eating vegetables will cause you to lose weight. So the change variable is, for the first experiment, you add vegetable. For the second one, you did not. Okay? So in this question, you're talking about the amount of sunlight, alright, affecting the growth. So the change variable that we are trying to explore here is actually amount of sunlight. This is the one that needs to be changed. Everything else needs to be exactly the same because this is the factor that you want to explore. Alright, so in this kind of experiment, right, you always want to identify that. Alright, so then the question asks, which of the variables should she keep the same? Just in case you all still don't know what is the meaning of variables. Variables just means conditions or factors in an experiment. So what do I mean by that? So for example, conditions could include things like is it indoor, is it outdoor, is it in an open field, is it in a lab, is it in a dark room, is it a light room? These are called conditions. What's the temperature? Is it freezing? Is it very hot and sunny? Okay? Factors will include things like, for example, what kind of beakers are you using? Glass beakers, plastic beakers, how big of a beaker? Is it 250 ml of water, or are they the same? So these are called factors or variables in scientific terms. So remember, I told you that everything needs to be kept the same. Alright, the only difference that you should be changing is what you want to explore. In this case, the amount of sunlight. So do we need to keep the size of the plant same? Yes. Not just size, but the type also. Okay? Amount of water given to each plant? Yes. Location where each plant was placed? Probably no. Okay? Why? Because actually we can actually relate location to sunlight. Okay, whether you keep one in the open field in the garden, you get actually a lot of sunlight versus one in the dark room. So when it's in the dark room, you don't get any sunlight. Now, however, remember, MCQ questions is always about the best possible answer. Now, this answer here, I have an issue with it. D. Why? Because even with location, right, I'm very uncomfortable with the fact that they use the word location to relate to sunlight. Here is why. Imagine you put one pot of plant in the lab and one pot of plant in the open. Besides amount of sunlight, can you think of other factors that would be different? Yes, Ethan?
Whether the temperature is
Exactly.
higher in the open or
Exactly, that's what I meant. So yes, so in the open garden, the temperature could be higher because of the sun. So the sun doesn't just provide more light, it also provides more heat. So in that case, is it a fair test? No, correct now. Okay? So because in this case, alright, your best answer, you know that definitely you want something to be different. Okay? So the different part, right, we think that it should be related to the location in that case. So if I'm going to conduct a very, very fair experiment in this case, okay, I would actually modify this experiment. Okay, this is extension question. I would modify this experiment, okay, and I would say to conduct, okay, 2 experiments in a lab. And then I would place a lamp for one plant and the other none. So in this case, of course, I keep the plants well separated or 2 similar labs, because when I close the lab door, we assume that it's totally dark. So I have 2 separate labs, but they are exactly the same. One of the plants, I provide a source of light. Okay. I know some of you are going to say, oh, but light, they also would give off heat, but it's negligible. That means we can ignore it because it's a very small minimal amount. Ethan, you have a question? Don't have. Okay, so I would modify the experiment in such a way. So however, the one that you do not want to keep the same in this case is D. Okay, we relate this location, we equate it to having sunlight and no sunlight. So the answer should be A, B, and C. Answer 2 is your best possible answer. Okay, because there is no option where it says A, B, C, and D. Like I tell you, I have an issue with D actually, but since they don't have an option with A, B, C, and D, my best plausible answer is A, B, and C. These 3 needs to be kept the same. Okay? By right, location should be kept the same also, but you put a lamp for one and no lamp for the other. Yes. If they give you A, B, C, and D, then you need to think very carefully what is the intent of the question. I would still go with A, B, C, okay? Because perhaps, remember I told you best possible. So I will still equate it, I will equate location to sunlight in this case also. Alright? Because there must be a reason why they put it there. But in actual fact, I have an issue with the statement here. Okay? Moving on. Study the 2 plants A and B as shown in the diagram. Which of the following is true about the functions of part X and part Y? So you take a look at it. Okay? First identify what is actually X and Y. So X is actually your stem. And Y will also be your stem. Alright? They are both your stem. Now, this question, alright, the topic on this will be parts of your plant. Okay, whether or not you know the function. Okay, so remember we actually learned about the different plant parts. So let's do a very quick revision on it. We learned that this is actually your leaf. Now, the function of your leaf is to actually, I hope you all still remember, it is actually to carry out photosynthesis. I know a lot of you don't know how to spell photosynthesis, okay, but it's good to learn because Make food is accepted. However, why you should learn photosynthesis is because in secondary school, secondary 1, straight off, make food wrong. We do not accept it anymore in secondary 1. So, and if you don't correct yourself from the start, when you reach Sec 4, you have an issue. I have students, ex-students that have issues with this. Alright? So then after that, we also have roots. Now the function of roots is to absorb, okay, water and mineral salts, okay, from your soil. So whenever you talk about function, you should always tell me, especially when it's a transport, when the function is a transport. What do I mean by that? For example, okay, roots is to absorb water from where to where. Don't just tell me, oh, absorb water, but I need to know where is it from and to where you want to go. Alright, so it's very important. Now, which part of the following is true about the functions of part X and Y? So part X and Y, they are both the stem. Okay? Now, remember, it is always the best possible answer. So if you take a look at it, both part X and Y make food for the plant. Okay? Do you think it's correct or wrong? Do you think it's correct or wrong? Who thinks it's correct? Who thinks it's wrong? Put your hands down. I'm going to tell you something that's very shocking, okay? Parts X and Y, right? They do make a very small amount of food. Okay? They do. Now, give me a chance to explain this. The pigment that you use to actually make food, if you know, is called chlorophyll. It's green in color, correct? Which is in your chloroplast. Right? You should know this because you have made your plant cell. So plant cells, especially those cells found in your leaves, will contain chloroplast, which contains green pigment chlorophyll to photosynthesize. Now, what color is your stem? For some of the plants?
Green.
Green, yes. So for some plants, you realize that the stem is actually green. This tells you that it contains what? Chlorophyll, which is able to actually make food. However, this is not true for all plants. This is not true for all plants. If you have like a tree trunk, what color is a tree trunk? Brown. So it doesn't contain chloroplast. Okay? In certain plants, like for example the cactus, you will notice that the cactus, the stem is what color? Green. The stem of a cactus is green because the plant is specially adapted in such a way that the chloroplast, a lot of them happens in the stem. So in this case, alright, we always go for the main function. So the main function of the stem is not to make food. So therefore it's wrong. Then why am I telling you this, teacher? Is it to just to confuse us? No, I'm not trying to confuse you. I'm trying to tell you that, okay, a lot of things, there are special circumstances. Alright? But we're looking at the typical, the most common one. Just like a typical cell, animal cell will contain nucleus, correct? But your red blood cell has no nucleus. Okay, so if you watch my video tutorial, you will have known that the red blood cell is a special type of cell. And that happens a lot in science. Okay, number 2, both parts X and Y hold the plants firmly to the ground. That's wrong. Whose function is it? Roots. And number 1, they are your leaves function. Number 3, both parts and Y absorb water and dissolve mineral salts. Nope. Whose function is it? You have roots. And then number 4, both parts N and Y transport water and food to other parts of plant. Correct or wrong? Correct. Okay, we've learned that in P3. So your stem actually contains, okay, parts N and Y your stem, they contain water and food carrying tubes. So this helps to transport water as well as nutrients around the plant. Okay, that's how it works. Okay, moving on in 5, 4, 3, 2, and 1. Next question. Anne kept a plant in a beaker of water near the kitchen window as shown below. Which one of the following graphs correctly represents the change in amount of water in a beaker after a few days? Okay, now, so what it means is that you need to read the graph. So the first one, you see, as the number of days increases, okay, maybe I should use a thicker line. As the number of days increases, you're telling me the amount of water also what? Increases. So what you're trying to tell me is that, wow, the water will magically appear. True or false? False. So this is wrong. Okay, why? Because we know that the plant will take up water for photosynthesis. So 1 is wrong. Okay, let's look at the wrong ones first. Let's look at 3. 3 is also, I can tell you straight away, is wrong. Because what does it mean? As the number of days increases, what does it mean?
The number of water remains the same.
Yes, the amount of water remains the same. That means your plant doesn't use any water. Okay? Number 4 is also not correct. Why? First it decreases, then it increases very sharply. Also not correct, right? Okay, that means water has decreased to this level, then suddenly magically all the water started replenishing again. Cannot, right? Unless someone pour water. Did they say someone pour water? No, they didn't. So you need to actually understand what it means. Okay, ask yourself, how come the water will slightly go up? So whenever you do graph reading, right, you need to do this. First read the horizontal line, then read against your vertical. This is horizontal, and this is your vertical axis. Okay, this is your x-axis, this is your y-axis if you learn math. The correct one is actually number 2. Why? Because as the number of days increases, okay, my amount of water actually decreases. Can you see? It's dropping. It's dropping. Alright? Now, you also need to understand that in some questions, they will tell you that there is a layer of oil. Why they put a layer of oil? Now, the layer of oil here is to prevent, yes, water from evaporating. Now, why is that? Why is that important? Okay. Now that is important because they want to see whether or not the plant is able to absorb water. So any loss in water, right, is due to the plant absorbing the water and not because it has evaporated. Because if you don't put a layer of oil, people can say, oh, water loss is not due to plant. Water loss is because it evaporates. Right? So how do you prevent that? Oh, put a layer of oil so water cannot evaporate. Okay? Moving on. Question number 20. Study the diagram below. Okay? Which of the following non-living things is made up of only one material? Okay? So basically, first things first is on classification. They ask for non-living things and one material. There's 2 criteria over here. So, shoes. Shoes, is it made out of living or non-living things?
Living.
Okay? Living. Okay, because it's a leather, right? Okay? One material. Hold on, let me think. I need to think. Non-living things made from only one material. Okay, guess what? They are all non-living things. Correct? So one material. So your shoes, okay, usually this part here is made of what? Rubber. Okay, some of them can use metal because you know why? They nail the sole of it to the leather. So this part is leather. So this one wrong already. Pencil, this is lead and this is wood. So wrong. Computer, this one glass and plastic. Wrong. So handkerchief is cotton. This is the only one that is correct. Answer number 4. Okay, very straightforward, this one. No need to even go and think so much. Alright, study the flow chart below. Which of the following is likely to be a plastic ruler? Okay, so firstly, is a plastic ruler strong? No, not very strong, right? Okay, strong that means you bend it won't break. It's not very strong. It cannot hold heavy things also. Okay, so it's no. Okay, is it waterproof? Yes, right. Plastic is waterproof, right? Is it flexible? Yes, right. You can bend a ruler and you'll go back to its original position. So answer D. Very straightforward, this question. Okay, 22. The diagram below shows a hammer which is used to hit a nail in the wall. Which of the following materials are most suitable for making the parts labeled X and Y? So to answer this question, right, this topic is on materials. You need to know the properties of certain materials. So the part that hits the nail needs to be very strong. Correct? Okay? The part that is forming the handle of the nail also needs of the hammer also needs to be what? Relatively strong. Okay? So let's see. Okay? So the first one, can it be a glass? No, because glass is actually hard, but it's not strong. Meaning that when you actually drop it, it will break. Okay, it's brittle. So this is wrong. Can it be plastic? No, right? Because the nail, which is made of metal, is actually stronger than your plastic. So when you use your plastic to hit, yeah, you will dent the plastic. So wrong also. Can it be metal? Yes. Then you check. This can be wood also. Now, the handle over here should be something that is lightweight also. If not, can you imagine it's going to be so heavy? Yeah, right? So wood fits the bill. Okay? Alright. X cannot be ceramic. If not, you'll be hearing a lot of crashes. Now, study the classification. So once again, the word classification is there. You know it's classifying. Which one of the following objects has been classified incorrectly? Okay? So you take a look at it. Alright? The heading over here is magnetic and non-magnetic. So let's revise. Okay? Magnetic objects is C-O-I-N-S. Correct? Okay, C stands for what? Cobalt. Okay, cobalt. Okay, sorry. I think I spelled that wrongly. Cobalt. Okay. Oh, CO, correct? Cobalt. And this is A, correct? And then after that, iron, then nickel, and then after that, S is steel. Steel. Okay? Copper, iron, nickel, steel. Okay? So you take a look at it. Aluminum foil can or cannot? Cannot lah. Straight away, this one wrong. Iron is okay, right? Steel is okay. Check non-magnetic objects. Silver, non-magnetic. Copper, non-magnetic. Ruler, wrong. Not wrong. Copper, non-magnetic. So your answer would be number 4, aluminium foil. So you need to remember, okay, coins. Yes, Ping Rong? Okay, next. Okay, Irene coiled a piece of wire round an iron nail 12 times before connecting both ends of the wire to a battery. The electromagnet was then brought near some paper clips and it did not attract any paper clips. So straight away, you see there are key terms that can help you identify. You see things like wire round iron nail, you see words like electromagnet. So the topic that they're testing you on must be on magnet. Okay, I'm not quite sure what concept yet. Okay, let's see. Now, they then tell you that, oh, it did not attract any paper clip. What could be the possible reason? So this concept is actually testing you on circuit. Okay, to see whether you know that everything must be connected properly. So, the battery was spoiled. Possible or not? Yes, right? Possible what? Battery spoiled already, then cannot power the whole circuit. The wire was made of copper. Possible? No, because you are supposed to use copper. Copper is a good conductor of electricity. The paper clips were made of plastic. Oh yes, that's possible. Okay. The iron nail had been hit with a hammer several times before the wire. No. This one is for what? Okay, this will happen for what? If it's hit by a hammer several times. This is only happening, will only affect what? Sorry. Affect magnets made by what? Induction method. You remember induction method? The stroking one? When you use the magnet to stroke, and then after that it becomes magnetic. You remember that? Use another magnet to stroke. Then when you drop it, it loses its magnetism. So your answer will be A and C. Answer 1. Okay? Moving on. Last question, right? Okay, Liner conducted an experiment using two similar ring magnets A and B as shown below. He observed that both magnet A and B were floating above plate A in the diagram below. So once again, the topic would be on magnet. You already see so many keywords already. Now, floating. So sometimes experience, right, can help you identify the concept. So the only way that magnets can float, right, is where they are like poles and they are repelling against each other. So the concept that they are testing you would be on, okay, like poles repel and unlike poles attract. Very good. So this is the concept. Alright. So they ask you which of the following statement is true. So based on this, right, you would know that this facing and this facing must be the same. I'm going to color code it. Color code it means the same. So because it's the same, right, they will repel, okay, causing it to float. Now for plate C, right, it has to be magnetic as well. Why? Because only when plate C is magnetic can it actually cause your magnet B to float as well. That means this surface and this plate here, they are like poles, and what happens is they will also push against each other. They will repel. So because they are like poles, they will repel each other, causing your magnet B to float. Okay? So obviously this surface is blue now. Alright? So which of the statements is true? Plate C was not a magnetic material. This is wrong, because plate C has to be a magnet. Magnet A was lighter than magnet B. No, they told you what? Two similar, so wrong. The unlike poles on magnet B and C were facing each other. So unlike pole, this is also wrong. Okay, because if B and C, okay, were facing each other and they are unlike, they should, instead of repelling, they should actually what? Attract. Which did not happen. They actually repelled, right? So this did not happen. the light poles of A, B, and C were facing each other. Okay? A, B, and C, yes. So answer number 4. Okay? So it's only with light poles then they repel. Oh, still got 2 more questions. Okay, so we will stop here for today because now let's start. Okay, so question 26. First things first, remember I always tell you, look out for the topic and the concept. So Alice carried an experiment using magnets A and B. She placed magnet A at one end of a plastic ruler and a paper clip at the other end of the ruler as shown. She moved A along the ruler and stopped when the paper clip was attracted to magnet A as shown in the diagram. So straight off the top, this would flag off as a topic should be magnet forces of magnet. Okay? And the concept over here that you should actually get, right? Okay? You would actually look at it and go, oh, okay, I have distance. I have distance over here. I'm looking at moving, okay, the magnet until it starts to attract. So at the back of your mind, you'll be thinking, okay, what are they trying to determine? They've got 2 magnets, they repeated the experiment, alright, and they have a ruler. So in this case, you should get an idea that they're trying to see which magnet actually has a stronger magnetic force, okay, or magnetic strength. Now, you need to be very careful. Once again, I want to stress that you should not say things like A is a stronger magnet or B is a stronger magnet, because stronger in material actually refers to the material being able to break easily or not. That is strength. So you have to say something like, oh, magnet A has a stronger magnetic force or a greater magnetic force as compared to B. Once again, when there is more than one item that is being compared, you must use comparison words. If it's only 2 items, you use stronger, higher, faster. Okay, if it's something that's got to do with more than 3 or more items, you will say things like, oh, strongest, weakest. Okay, comparison words. So once, like what I told you, she then repeated the experiment using magnet B. Okay? Alright? So what is the aim of an experiment? So, like I told you, from this experiment, you need to recognize that the concept they are testing you is on magnetic strength. So obviously, the stronger the magnet, okay, the shorter the distance. Okay, distance is over here. I'm going to highlight in pink color. Okay, the stronger the magnet, the longer the distance, alright, it would need to be. Because it means that the magnet can be at a further range, okay? Further range from the paper clip, alright? So the magnet, if it's not a very strong magnet, you will need to go very close to the magnetic object before it will attract the object. So while on this, I would also like to revise with you certain basic concepts on magnet. So certain basic concepts will include things like opposite poles attract, okay, like poles repel, alright, and I hope all of you always remember, okay, the abbreviation points, where CO stands for your cobalt, I stands for iron, N stands for nickel,
Steel.
and S stands for steel. So these are your magnetic materials. All other metals at your syllabus, no. Okay, aluminium, copper, all this, no. So this is very important. So what was the aim of the experiment? It was basically to find out the, is it strength of paper clips? Do paper clips have magnetic strength to them?
No.
And not only that, they mentioned about strength. So they're actually, when they say that, means that the experiment want to see whether or not the paper clip can break easily. So that's not the case, right? To find out the magnetic strength of A and B, this is the correct one. But remember I told you in MCQ, you always want to be extra careful. So make sure you look through your options. 3, to find out the material used to make magnets A and B, that's not true. 4, to find out if paper clips are made of magnetic materials, that's not true. Okay, now if I wanted to find out if paper clips are made out of magnetic material, do you think I need to actually even use 2 experiments? No, I just need to use a magnet, and I will just put the magnet very close to the paper clip and see if the paper clip gets attracted. If it gets attracted, it means that the paper clip is of a magnetic material. It's as simple as that. So best answer, number 2. It's as simple and as clear cut as that. Okay? Moving on, which of the following statements are true about uses of magnets? Okay, so this is got to do with your memory base. Okay, we call it knowledge based question. So it's you really need to study. Unfortunately for science, it's got to do with a lot of content. It's either you know or you don't know it. Okay, math, not so bad. Math, a lot of times, you know, it's got to do with reasoning. You can figure out the formula and things like that, add, minus, subtract. There's only 4 things. My prof used to tell me this. Mathematics is the easiest subject because there's only 4 things that you can do. Right? Okay, at your level at least. Okay? Divide, subtract. Okay? Multiply. Okay? And what's the last one? Add, yeah. Okay? Now, so maglev trains, yes, that is correct. If you remember, the maglev trains are trains that actually so-called float. Okay, just a quick revision. So if this is the train, okay, and then this is the train track. Okay, it is floating. Can you see there's empty space? Now what happens is that it uses electromagnet, very strong electromagnet. And what happens is that they make the poles repel, okay? So causing the magnet at the bottom here and on the track, okay, to be opposite poles so that it floats, reducing friction, okay? Magnet keeps the refrigerator doors closed tightly. This is also true. Magnets are used in compasses to tell direction. This is also true. So therefore, your answer would be A, B, and C, all 3. Moving on to question 28. Okay. Ali conducted an experiment to find out about the strength of 4 bar magnets A, B, C, and D hung from a wooden pole. He lowered each bar magnet slowly and stopped when it attracted all the paper clips as shown, okay, below. Alright? The table shows the distance the magnets could be lowered before all the paper clips were attracted. Now for this kind of question, it's pretty straightforward. You know that the concept they want to test you on is magnetic strength. However, I want to caution you that, okay, for the concept of magnetic strength, they like to use this distance between magnet and magnetic object, okay? Distance between magnet and magnetic object, okay? We're going to call this D for distance. Now, you need to understand that this concept is always, why students get it wrong is their mind gets twisted. Okay, they are confused. They always think that the bigger the number, the better it is. However, in this concept, it is the opposite. The smaller the distance, okay, it means the weaker the magnet. Okay, that means the smaller the distance is between magnet and magnetic object before the object will get attracted to the magnet, the weaker the object. Because a stronger magnet is able to attract, okay, object at a further distance away. It doesn't have to be so close. Only a weak magnet would need to go so close to the object. So you need to be very careful. This is the part that a lot of students make this careless mistake. And this type of question is the same thing as time. As time. Students always think that the faster the object is, they know that they should take a shorter time. But when they write, they always write the one with the longest time. Because they sort of correlate a bigger number to being better. But no, when I want to find out who is faster, say you got two runners, A or B. The one with the shortest time is actually the faster runner. But they always tend to put the wrong answer because bigger number means better usually. Okay, but no. So this is one of those questions that is always very tricky. Okay, so then they give you a table. They ask you which magnet A, B, C or D had the greatest magnetic strength. The answer over here would be the bigger the better. Okay, the bigger the better. All right. Okay, so in this case the answer would be your C. Okay? Yeah. So this is the type of question that you really need to careful and think. Are they asking for the weakest one? If they're asking for the weakest one, then the smaller distance is better. If they are asking for a magnet that is of stronger, then the greater the distance, the better. Okay, but you must understand why. Because with a greater distance, and yet you can still attract, it means that the magnet is very strong. However, for time, the shorter, the faster. Okay? So you need to be careful. Alright? So in this case, the weakest is A. Alright? Oh, and also read the question. This is actually greatest. So this is where you tend to get errors.